Hello grade 7 students, this is Mr. Saleh. Today we are going to start our new lesson, lesson 20.1 magnets and magnetic fields. In this lesson we are going to study magnetic pole, magnetic force and ferromagnetic materials. So let's start. What are magnets? A magnet is an object that attracts the metal iron object. For example, a paper clip. Paper clip is a metal can be attracted by the magnet. Magnets come in many shapes. As we can see here, different magnets with different shapes. What's magnetic poles? Magnets have two poles, a north pole and a south pole. As we can see here, every magnet has two poles, S and N. Between the poles there is a magnetic force. The magnetic force very strong at the poles. So at the poles there is a strong magnetic force. So every magnet has two different poles, S and N. What will happen if you break the magnet? As we can see here, if you break a magnet into pieces, each piece will have a north and a south pole. So as I said, between any two magnets there's a magnetic poles. As we can see here, if we put two same poles close to each other, S and S, they repel. Also N and N repel. What will happen if we put two different poles like N and S? As we can see here, if we put N and S, they attract each other. So same poles repel and different poles attract. As I said, between any two magnets there is a magnetic force. This magnetic force depends on the distance between the two magnets. If the distance between magnets increases, the magnetic force decreases. If the distance decreases, the magnetic force increases. Magnetic field lines. Around any magnet there's a magnetic field lines. As we can see here, around the magnet there's a magnetic field lines. So what's the direction of the magnetic field line? The direction of the magnetic field line is from the north to south. As you can see here, the direction of the magnetic field lines from N to S. Also here from N, from outside from N to S, from inside from S to N. Where is the magnetic field strongest? As I said, the magnetic field is strong, very strong at the poles. So here at the poles there's a magnetic field which is very strong, magnetic field. So the magnetic field is very strong at the poles. So as I said, different poles attract, same poles repel. Here repel, the two magnets repel each other. Here the magnet attract each As we can see here, in the first case, the magnetic field lines are combining. In the second case, the magnetic field lines are separating. Well, Earth has a magnetic field. Also, Earth has two poles, a north pole and a south pole. Also, the direction of the magnetic field from north pole to south pole. Compass. A compass is a device we can use it to get the direction. So what's compass? It's a small instrument that contains a needle from inside it. So inside the compass there's a needle. Here the needle. This needle, it's a small magnet. Has two poles N and S. So compass, it is used to identify the direction. The Earth, as I said, the Earth has a magnetic field. The Earth's magnetic field exerts a force on the needle, causing it to rotate. If we put a needle close to a magnet, if a compass needle, we put it very close to a magnet, the magnet will exert a force on the needle, causing it to rotate. What is aurora? Particles from the sun can travel along the Earth's magnetic field lines and concentrate at the magnetic poles. The particles from the sun collide with the atoms of the atmosphere. This can cause aurora. The particles that come from the sun concentrate at the poles. These particles, they will collide with the atoms in the atmosphere in order to cause aurora. As we can see here, different magnetic materials. What is magnetic materials? It's a material can be attracted by the magnet. What's ferromagnetic materials? Ferromagnetic materials are elements including iron, nickel, and cobalt. So ferromagnetic materials or ferromagnetic elements have strong attraction to magnets. Not all the materials are magnetic. What's magnetic domain? Magnetic domain is a region in a magnetic material in which the magnetic fields of the atoms all point in the same direction. Here, as we can see here, all the atoms in the first region, all the atoms have the same direction. So this is called magnetic domain. Magnetic domain. What I mean by magnetic domain? When the atoms, all the atoms have the same direction. As we can see here, all the atoms have the same direction. So this is called what? Magnetic domain. Magnetic domain do not line up. As we can see the difference between the first figure and the second figure. So in the first figure, there's different domains. In the second figure also there's different domains. In the first figure, not all the atoms have the same direction. But in the second figure, all the atoms have the same direction. All the atoms have the same direction. Here, as we can see here, three different pictures. Picture number 1, number 2, and number 3. What the difference between the picture number 1, picture number 2, and picture number 3? In picture number 1, as we can see here, the atoms are not aligned, so there's no magnetic domain. So what we can say about picture number 1? Picture number 1 is a non-magnetic material. Why it's a non-magnetic material? Because there's no magnetic domain. Let's go to picture number 2. As we can see here, there's a magnetic domains. Can we say it's a magnetic material? Yes. Why? Because there's a magnetic domains. As we can see here, the atoms, not all the atoms have the same direction. Picture number 3, there's a magnetic domain. What the difference between picture number 2 and picture number 3? In picture number 1, as we can see here, there's a magnetic domain, but not all the atoms have the same direction. Picture number 3, there's a magnetic domain and all the atoms have the same direction. So what we can say, picture number 2, a magnetic materials. Why it's a magnetic material? There's a magnetic domain. Picture number 3, it's a magnet. Why it's a magnet? There's a magnetic domain and all the atoms are aligned. What will happen if we put here, there's a magnetic material. Magnetic material. Why it's a magnetic material? As we can see here, there's a magnetic domain. What will happen if we put a magnet close to the magnetic material? If we put a magnet close to the magnetic materials, what will happen for the atoms? The atoms will align. As we can see here, all the atoms have the same direction. Can we say now the magnetic material now it's a magnet? Yes, for sure. Why it's a magnet? There's a magnetic domains and all the atoms have the same direction. The magnetic field around the bar, here there's a nail. If we put the magnet close to the nail, what will happen for the atoms inside the nail? All the atoms will be aligned. All the atoms have the same direction. If we put the nail close to the paper clip, as we can see here, the nail attracted the paper clip. So the nail becomes a temporary magnet. What's temporary magnet? A magnet that quickly loses its magnetic field after being removed from a magnetic field. So permanent magnets, a magnet that remains a magnet after being removed from another magnetic field. So what we can conclude, so there are two types of magnets, temporary magnets and permanent